Hello everyone, thank you for watching my videos. We have been seeing in the series of videos where we are talking about machine learning foundation, we have understood now what is data till now. What is the data, how is it created, and how the machine actually sees it. Now in this video, we will see what is called the model. What is a model? We will deep dive and understand what is the connection between the model and the data and how the machine learning actually gives us the output for our queries. We will also see what are different types of models and the specifications on how they work. Let's jump into the video. First, we will, as usual, take the analogy of recipe what we have been doing till now. Data we understand is the fuel. What we saw, what is the data? Clearly recap. Data is basically given usually in tables, okay, with various heads and line items. And we also saw how the computer sees it, like they convert the data into something called the vector. Okay, if you have not understood or don't realize how the computer sees the data and understands the data, please watch my previous videos before coming into this video. Okay, we understood what is the data and how we get it and how the computer analyzes the data and understands and assimilates the data. The next step is for the model. It is the engine. The data is the fuel and the model is the engine who is going to operate. Okay, or we can also say the model is like the recipe. If data is the ingredient, the model is the recipe. If data is the fuel, then model is the engine. Okay, recipe, what it does, it actually gives of what we should do with the data. Okay, it is as simple as that. Okay, if we get the data, what we should do with the data, that's what model tells you for giving you the output. Without data, the model has nothing to learn from. Okay, if you give more and more data, the model learns from the data. If you remember the first video we started, we are no more giving any codes or anything, any algorithms to the machine. It itself is learning and developing the code. So it is very, very important for us to give more and more data so that the machine learns on its own. And without the model, data is just noise. For example, if you have all the ingredients you need but don't know how to cook, you don't have the recipe, obviously the ingredients are of waste. Output is the movement of the machinery. So if the machinery moves, then you get the movement. That is the, if you give a query to the model and it gives you the reply, that means the data is already fed into it, the model has read it, it knows what to do with your query and then gives you the result. Okay, in case of ingredients and recipes, it gives you the finished product or the finished dish because you have the recipe and the ingredients. What is a model? It's a complex reality converted to a simplified model. So basically you have here, I have shown an example of an aeroplane which is very, very complex machinery. We also make models of the same aeroplane to test various parameters. Like you would have seen that the scaled down models are made of the planes and they are tested for their how good they do with storms and in case of windy conditions, how they are able to sustain. All those things are tested in the model. They are exact replica of the original model, or original plane rather, but they cannot be considered the original plane for obvious reasons. So the model is basically something like that. So what we are going to do in a model is very similar. That's why it's called a model, where we are going to scale down the reality of the world. Okay, we are going to scale down the reality of the world and put it into some calculation. Obviously, you have so many parameters that you cannot exactly replicate the complexity of the world into a single calculation, right? So it can never be correct, but some models can be useful for understanding the world. Okay, that's what is about model. A model is a mathematical simplification of reality. Okay, that's what I told you. You have the whole world, you have certain portions of the world, and we want to simplify the whole world into a single equation. Okay, if you put an input like this, you should get this out. Okay, that's what we are going to actually try using this model. Think of a model aeroplane like what we have done here. It's not the real plane, but it is useful for testing. We use the simplified model for all kinds of testing. Models simplify the complex reality into something we can compute. We cannot, build the whole actual plane and then put it to test, right? So there might be some destructive tests which can be done on the plane where one plane can be tested, but you cannot test all the planes which are manufactured like what we can do it in a model. That will be too expensive for manufacturers. Okay, so that is why we make a model of the actual complex aeroplane. All models are wrong, but some are useful. Okay, this is a very, very perfect statement of what we are going to do with these models. Okay, models can never be accurate. They can be very close, or rather somewhat close, but can never be accurate. But some models can actually help us understand some part of the world better where we are living in. This is a very, very important statement. All models are wrong, but some are can. Remember this. There are two big buckets when it comes to model. One is what we talk about is the predictive, and the second one is what we call the probabilistic. So in the first one, we give the data, the actual data, including what was the result. For example, I did A thing, I got the result B. I did a activity C, I got the result D. I did an activity E, I got the result F. So I give all the data including the result what I got. So based on that, the model predicts if I give a new thing, if I give Z, what will be the result based on all the information I have already given it from A to Y. That if he did activity A, he got B. If he did C, he got D. So in that same series, if he did Z, what will be the result? That is what model does in the predictive bucket. And the probabilistic bucket, we don't have the right hand side. That is, if I did the activity, or I had the activity A, but I don't know what happened to the result. So if I give you a picture of a cat, I don't know what it is called. I give a picture of a dog, I don't know what it is called. So what I give it, I just give random pictures of only cats, only dogs. So what the model has to do, has to actually learn from only one side of the data and understand what, if I give you a new thing, okay, if I give some other new animal, so it has to classify and see whether it can be a dog or a cat. Okay, so because it doesn't have a very clear result of what the previous activities or for what the animals gave. So it doesn't know a dog or a cat. It knows maybe it has you have characteristics of dog, or it has characteristics of cat, and it matches those and says it is matching the characteristics of dog or a cat. For us it is dog or cat. For us, it is just the parameters of cat is closely matching to what you have given, or the parameters of the dog is closely matching to the what image you are given in the new image which you are given is an input. Predictive models tells you what will happen. There are two types of predictive models. One is called the regression, that is, example, house price is 4,50,000 USD, and classification, prediction, that is email, is it spam or not spam. Regression is basically a continuous number. Okay, there is no gaps here. Okay, it cannot be 4 lakh and then it cannot be 4 lakh. This is 5 lakh. This is 6 lakh. It cannot be like that. It's a continuous line. It can be 4 lakh $1, 4 lakh $2, maybe 4 lakh 0.0001 dollar. So it is actually a continuous line. Okay, there is no break. That is called the regression. Okay, in case of classification, the answer is yes or no. For example, you give a picture and you ask it, Is it a cat? So it will tell you yes or no. It's a cat. No, it's a dog. Or rather, if it is a cat, yes. If it is a dog, no. Okay. And email. It is a spam or not spam. Okay. In case of the predictive models, you have further division of two divisions, which is one is the regression and second is the classification. Clear till now? So basically what we are doing is what will happen is what we are doing in the predictive kind of a modeling. That is the first part. Second part is the probabilistic model. Tells you how likely something is. Okay, gives confidence scores, not certainties. Okay, maybe I use the wrong example of cat and dog in spam or not spam, because here we would have already given examples of what is a cat or what is a dog. Then it can, you can use it. Is not that you cannot use. See, what you can do is you are given an image and then tell this is a cat. You can give hundreds of images and you can tell these are all images of cats. Okay, now you give a new image and it can tell you clearly it is a cat or not a cat. Okay, you can still use it there, but in case of this probabilistic model, it is basically the grouping. You are not telling it's a cat. Okay, that's the difference. In this case, you have to tell it's a cat, then it will know. In case of probabilistic models, you will not tell it is a cat. It will not know what animal it is. It will not know, it will not put a label to it. That's what it is, the term which is called, you have labels here. This is a label. This is a label. Okay, we don't have any labels in case of probabilistic models, but in case of predictive models, you have labels. So here you will tell how likely it is a cat, how likely it is a dog. So for example, if you are given all the images of cat, but you are not told it is a cat, then it will, if you give one new image, it will tell it is 90% chance that it is a cat, 25% chance it is a dog. Okay, it is not certain. Okay, in case of it doesn't mean that predictive models are very certain. They cannot be always accurate. As I told you, all models are wrong, only some are useful. Okay, so we have to always remember that in the back of the mind. They give confidence scores. It is only the percentage and it never gives 100%. So what probabilistic model gives is how likely is it, is what we are interested. Example, face recognition. Okay, so I told examples of cat and dog. It can be your face recognition. Okay, so if you have a camera and or your face recognition on your phone or laptop, so it recognizes your face, right, for logging in. So that means it has recognized your face to a certain level. It may not have recognized it 100%. It might be at a certain threshold, what is set in the system, maybe 80% fitness or 90% fitness. So you would have seen sometimes, twins are able to use the phone, the same phone with the same face ID. So maybe the features are there, so it predicts it is the same person. Example, credit card fraud, 87 probability. So we know, okay, we have cases where the credit card has frauded and fraudulent, and the person who is doing the transactions and what kind of transactions has been done for becoming the fraud transaction. So the system can find out what is the probability of the transaction being fraudulent or genuine. Next is a simple thing where a lot of confusion happens. I may also mistakenly used these two words interchangeably sometimes, the model and the algorithm. Model, what we told till now, is the recipe and we get the output. So what is algorithm? Algorithm is how this recipe is made. This is also a process, right? How made. And recipe is the output. So this is also the final product and this is the process. Okay, the process of making the recipe is called algorithm. Understand very, very simply. Okay, you can see the whole process here. You have the data, you have the learning process, which is the algorithm. Algorithm creates the model and model does the prediction, gives your result. You have the data, you have the learning process, So maybe it can be your grandmother's processes, she has tried it many times in different methods to finalize one recipe which she gives you. You tell that is the grandma's recipe. How did she come about getting that recipe? She has trained many combinations to finalize this recipe, and then she gives it to you as a model, and then model does the prediction. So if you see the data, if you see, it is the raw ingredients, and then the algorithm is the chef, or in this case our grandmother, who is experimenting and learning, and then she gives you the recipe. Finally you can use it. In case of data, again you can see it is the data, then you have the algorithm which processes, then you get the model and you do the prediction. Model is the recipe, that is the final product of the algorithm. The recipe itself is the final product, and the output is another final product which we get from but querying the model. Mathematical rules and formulas learned from data. Mathematical rules and formulas, this is the final mathematical rule and formula. The model is made of mathematical rules and formula which is final. There is no changes in it. It can have different models. So every model is different. Every model will have different code, but the code for the model is final. It is learned from data obviously, and the model makes prediction. Example, if square feet 2000 price is 450k. Okay, this is the prediction it has made. As I told, we have given the predictive model. We have not used the probabilistic model, we have used the predictive model here. Okay, so if you give square feet is greater than 2000, it will spit out the price as 450k. What is algorithm? It is the chef, the recipe creator. Here it is our grandmother. The learning process, okay, how it has come to this final mathematical rules and formulas, okay, the learning process, how the recipe is created. Example, linear regression, decision trees, neural networks. These are all the processes by which the model is created. We will go through all this in very minute detail. We will deep dive everything so that you are very clear of what is happening where. Okay, I think we are very clear about what is model and what is the algorithm. There are a lot of people who have this doubt, is algorithm and model is the same or it is different. I think this has cleared the doubt. So the key distinction is algorithm creates the model by learning from the data. Model makes prediction by applying the learned rules, the final rules. So it's a final mathematical formula which is learned by the algorithm. The next what you have to see is the algorithm. We will deep dive into the algorithm. Now we know the model, but who creates this? The algorithm as we saw it. What types of algorithms exist? How does an algorithm learn from the data? Which algorithm should you choose? Okay, these are all the points we are going to see in the next video. So don't miss my next video. And if you did like this video, please hit the like button, share it with your friends, and subscribe to my channel for more such very informative and deep dive videos. Thank you so much. Take care. Bye-bye.